Hello, Mr. Aaron, Mr. Ryan. How are you today?
Good.
Okay.
I'm good.
What's
And
average?
Ryan's too.
Yeah. What's average?
Oh, okay. So let me explain. So, okay. So let me.
Average.
Uh,
Average. Not why you draw a binary tree?
So what do I need to draw?
trying to show.
What do I need to draw?
No.
How do I need to? What do I need?
How
to
do you explain the average?
Okay. So like we like 1, 2, 3, 4, 5, 6, yeah, whatever.
Yeah.
Yeah. Okay. We do the count. No,
Yeah.
So then 1 is 1, and times it by 1 because there's only one character is 1, and this one is
Wow.
this one is
So what's the average of 2 and 3? What's the average?
Okay, so there's 2.5.
2.5. Yes. And then what's the average of these?
Okay, so there's 4 plus 5 plus 6 is
Divided by how many?
3.
Yeah, that's the average. So you just tell me it's a sum.
That's
It's a
15.
sum.
That's 5.
15 divided by 5
Yeah.
is
It's a sum divided by count. Okay, that's average, right? Simple as
And
that.
that's the sign, isn't it?
Yeah. So given a number like 1, 2, 3, a list of numbers 10, right? And I want you to tell me if it's possible to remove one number from the list, and the rest number, the rest numbers, the average will be 2.
That's.
The target will be 2.
Wait, how many numbers can we use?
So
So we're only allowed to take one number.
So we remove one of the numbers, and then the remaining numbers have
Oh,
average.
1, 2, 3.
We're done.
Easy peasy lemon squeezy.
Yeah, because 1, 2, 3, the sum is 6 divided by how many?
2. No, 3.
Yeah, so the original has 4 numbers, but we take one out, so the remaining will be 3 numbers.
Okay,
Right?
so this is how to work it out. So you find how many numbers. For this example, it's 4, and then if you take away 1, that means there have to be 3, and you do something divided by 3 equals 2, and then you need to find then 2 times 3 equals 6, and then you need to find a sum which equals 6.
Okay, interesting. Yeah, I'm not exactly following you, but I kind of understand what you mean. But look, so we given a list of numbers, and then we have a target. So you need to tell me if it's possible to remove one number to make the remaining numbers have average target. Return true or false, right? So what's your approach to check this?
Oh! Okay, so brute forcing.
Yeah, we're done. Brute forcing. How do we brute force?
Oh! Checking every possibility.
And how many possibilities of that? Like if there are n numbers.
I think it's n, because you need to take away 1, and then you know.
Okay,
Just
so
like
so if we take away these numbers, so what should we do next? So look.
Oh, we shall say remaining is 2 and 3 and 10, and then so then we add 2, add 3, add 10.
And then divided by count, and then we check
Yeah,
it.
which is 3.
Okay.
Well, and we divided by n minus 1.
We're done. N minus 1. Yeah, n minus 1. Okay, so look, if we take away this number, do we need to calculate the sum of these?
There's a wasp.
That's okay. We worry about it later. Alright.
It's
So
on the curtains.
yeah.
It's
So
quiet.
do you understand what I'm talking about?
Not really.
If I take away these 2,
Yeah.
how can I know immediately what's the sum of the 1 plus 3 plus 10? Do I need to calculate that 1 plus 3 plus 10? If I take away 3, how do I know exactly what the sum of 1 plus 2 plus 10? Think about it. What's the sum of 1 plus 2 plus 3 plus 10?
Oh, 16.
Okay. Then if I take away 2, what's the sum of 1 plus 3?
14.
Yeah. If I take away 3, what's the sum of 1 plus?
13.
Yeah, you got it.
Yeah.
So sum minus the number you take, right?
The minus is
Yeah.
91.
Okay. So you got it. Yeah. Okay.
Define.
Define. Check. Okay. Let's just check.
Define.
Numbers and target.
Cut. No.
Okay. Sum equals SUM number. So this is the sum of all numbers. Yeah. This takes ON time, right? Because we need to go through each number and add it together. This ON time, right?
Oh yeah.
And then now, for in nums, we try each numbers, right?
Cut.
Okay, then if I take away the number, look, if sum take away the number I, and what is it equal?
If s minus 1 I. Okay, so it's the sum.
If sum, I might take away the number, that's the sum of the remaining numbers. And what
So
is
we
it
just
equal?
take away it.
Yeah, we take away, and what is it equal with t?
Oh, we need to divide it by n minus 1.
Divided by n minus 1, so length, right? Num minus 1, right? And
Yeah.
equals what?
What?
Then what is it equal?
It equals the. If it equals the target.
Target. Okay, if this equals t, right? So you can times it. You can move this to the other side. It means to multiply, right? Yeah. So you
Column.
if t s minus I equals t times length nums minus 1, right? Okay. Yeah. Column. And then return.
2.
And what's missing?
Cut.
No. If everything is return true, and what should I return? If
Return false.
yeah.
Yeah, but yeah. Oh yeah.
What's the time complexity?
O. Pen. O and square.
N square. Why is
O
square?
1. O 1.
That's not possible.
O and again.
Don't guess, okay?
I thought it's these two, right? So O-N and the O-N.
This is ON and this is ON. So what's ON? What's the complexity?
2 O-N. 2 O-N.
If it's inside one another, that's ON square.
It's
This
2
is
O-N.
ON. This is ON. It's in parallel. So what's that?
It's 2 O-N.
ON. O2N, but you drop the constant.
Yeah,
right?
I just said O-2-N.
Okay.
I thought it was O-N square.
What's the space complexity?
O-1! Because they're not using any space. Blah.
Okay. Eric, look. If Eric, look.
Short.
This is I, right? If we move this to the other side, right? So we can write it as s minus t equals I, right? Yeah? Alright?
I equals S.
If I equals s times this t, right? Alright? Yeah?
So if I equals S,
Minus t times this, right?
that minus is so long.
Yeah. It's the same, right? Yeah? Because we eventually we want to find out if I is in one of these, right? If this number is in one I, right? Alright? Does it make sense? So we want to find out, look, for I in numbers, if I equals something, right? Yes? Alright.
Yeah.
Look, is this changing? S is not changing, right? We already know it. T is not changing, right? This is no one, right? So this, if I is something, right? It is already known, right? So what does it mean? We can do this one thing. Return sum.
We have 3 returns.
No, I'm talking about this 19. Okay, you don't need this. Okay, sum num. This is s, right? Minus t times ln nums
Well, that's gonna be so long.
minus r1. Yeah, this is the number, right? This is the number. We want to find out if it's in the nums, right?
I can't see.
Yeah, so what should we do? In nums. That's it. So all these 9 can be replaced by this one, right? Does it make sense? Yeah, it's looking good. Look, what's the if num equals 1, 2, 3, 4, right? Okay, so can you tell me 5 in nums? Is it return true or false?
Return in nums. Is 5 a target, you mean?
Yeah, 5 in nums. Nums is 1, 2, 3.
5 is not in nums.
So is it true or false?
False.
False. 1 in nums.
True.
True. So does it make sense? It's the same thing as for I in nums. If I equals 5, return true. Otherwise, at the end, return false. For I in nums, if 1 equals I equals 1, return true. Does it make sense, Eric?
So you're talking I is the number.
So this one in is means that we want to find out if this number if this element is in the list, right?
What's this complexity?
It's the same. Look, it's the same. It's just one num. Does it make sense? If we are finding, we want to find out in the numbers, right? In the nums, if there anything equals to this, right? So you can just do this. If this is in nums, right? It's the same thing, yeah?
Yeah.
Got it?
You gotta rub it out.
Got it? Does it make sense? Yeah?
Yeah.
Yeah? Got it?
Yeah. Are you kidding me?
It's easy today.
Okay.
Right?
Do you need to write 2?
No, just one of it. Any one of it. We want to find
I'll
out.
choose the shortest, the longest short.
Okay, can you do it? Do your best. Do your best. Come on. It's practice makes perfect, okay?
Ryan did the small one so fun. I'll just do both.
You want to return directly? Maybe this is not nice.
Wait, let me get return.
Return one none. What? Return Ryan. No. You want to do it, Eric, Ryan. Do it.
Okay, so
You two can help each other, okay?
bring it, look.
S equals. Yeah. We want to get the sum, yeah? Sum is lowercase, but it's okay.
Nums.
Nums, yeah. We want to get the nums, yeah.
Awesome.
Awesome. 快点 Some nums, and then what?
Some people won't understand you, babe. Some nums,
Yeah?
and then it is.
Want to take a look?
Hey, that looks like different.
It's similar, yeah?
Total equal. For I and num. For I and num. It looks different anyway.
Do you understand? If you understand, try your best to write it, okay, please?
Hey, look, that it says S is total.
Yeah. It's similar, but for I in what? In nums, yeah? You want to find out?
Oh, you forgot this.
Yeah. In nums.
Nums, color.
For I in nums, and we are trying to do, what are we trying to do, Eric?
Make this. Oh, we shall. Oh, if S minus I equals K times
T is T.
T
Equals what?
times length nums minus 1. So if
Eric, you understand. You don't need to take a look. You need to understand, right? You understand it before, right?
I equals T times. I don't know how do we do it, but I could just do a dot instead.
Yeah.
And now I do length nums.
I'm not making you look at it again. Right? Come on. It's
Length
easy.
nums minus 1.
Eric, can you explain? I mean, it's
Oh.
easy, right?
Oh, okay. So that's for some, and for you do. Wait, I'll just write it so for I something like that.
Yeah. Minus 1, but
No.
this bracket here. Yeah, and then color.
And if I is in nums, and then
the-
if
Return true, otherwise return false.
What did you put? Return is here. Return.
Okay, anyway.
And then return falsity.
Okay. Okay, that's it. That's it. Good job today. Good job. That's it.
Fuck!